Hey everyone, today let's talk about something you actually use all the time, especially if you're into gaming, the addition of vectors. Now I know it sounds a bit technical, but trust me, by the end of this, you'll see how super simple and logical it really is. Just think about it. You're playing your favorite video game, right? Your character runs forward, say, 10 steps. Then you turn right and run another 5 steps. The big question is, from where you started, where are you actually standing now? How does the game's code figure out your final, exact position on the map? Well, that exact scenario is a vector addition problem. Yep, each of those moves is a vector because it has a distance and a direction. To figure out your character's final location, the game has to add these vectors together. And what it gets is called the net displacement, which is just a simple term for the direct, straight-line path from your starting point to your final endpoint. So, how do we actually do this? Well, let's start with a really cool visual trick, something you can just sketch out to see the answer. It's called the triangle law of vector addition. Okay, the official textbook definition can sound a little heavy, I know, but the idea behind it is super simple. It just says that if you have two vectors happening one after the other, or in sequence, which is the key phrase here, then the third side that closes the shape to make a triangle is their sum. That's it. Let's break it down for our game character. It's just 3 easy steps. Step 1, take the start of your second move, let's call it vector B, and place it at the end, or the head, of your first move, vector A. We call this connecting head to tail. Step 2, now just draw one straight line from your original starting point all the way to your final ending point. Step 3, this new line, this shortcut you just drew, is the result. It's the vector A plus B. And this diagram here? It shows this idea perfectly. Look, vector A takes you from point A to B. Then, right from point B, vector B starts and takes you to C. The final result, the direct path, is just the line from the absolute start A to the absolute end C. See? Super simple, isn't it? Okay, so the triangle law is perfect for things that happen one after the other. But what if two things are happening at the exact same time? For that, we've got another really useful visual tool, the parallelogram law. The definition here has a keyword, co-initial. And all that means is that both vectors start from the very same point. So if you have two vectors starting from the same point, and you use them to draw a parallelogram, the diagonal from that same starting point gives you their sum. Let's think about our game again. Imagine you're running forward, and at that very same moment, bam, a strong gust of wind hits you from the side. Both of these forces, your running and the wind, are acting on you from the same point at the same time. This is a perfect scenario where the parallelogram law just makes more sense to visualize. So what's the big difference then? This chart makes it really clear. Triangle law connects vectors head to tail, and it's great for sequential moves. Parallelogram law connects them tail to tail, perfect for simultaneous forces. But here's the most important part, listen carefully. Both methods give you the exact same answer. They're just two different ways of looking at the same problem. All right, drawing is great for understanding, but for real precision, the kind of game's code needs, we have to calculate. So let's level up to the pro method, adding vectors using their components. Let's use this example from the NCERT textbook. We have two vectors, A and B. Now first things first, don't let the I, J, and K scare you. Seriously. They're just labels for directions. Think of I as the left-right direction, J as the up-down direction, and K as the forward-backward direction. That's all they are. Now, adding these is actually the easiest part, believe me. We just add the matching letters together. So first, let's combine the I parts. 2 plus 2 is 4, so we get 4I. Next, the J parts. 2 plus 1 is 3, so that's 3J. And finally, the K parts. Minus 5 plus 3 gives us minus 2, so we have minus 2K. It's just simple addition done 3 times. And there we go. The result, the final vector, is 4i plus 3j minus 2k. No drawing, no estimating, just a precise, calculated answer. This is exactly how a computer program would do it. Super fast and perfectly accurate. Now, just like any good video game, vector addition has some fundamental rules, kind of like the game's physics, that always work no matter what. Let's quickly look at a big one. This one is called the commutative property. It's a fancy name for a very, very simple idea. The order in which you add two things doesn't matter. So A plus B is the exact same thing as B plus A. Simple as that. And this diagram shows you exactly why this is true. Look at the parallelogram. If you follow vector A and then vector B, you end up at point C. Okay, but what if you follow B first and then A? You still end up at the exact same point C. In our game, moving forward then right gets you to the same spot as moving right then forward. Makes total sense, right? All right, we covered a lot, but you've done great. Let's just do a quick final recap to make sure everything sticks in your mind. So, what have we learned? First, vector addition is just about finding the one final result of many different movements. Second, for moves that happen one after another, we use the triangle law. Remember, head to tail. Third, for forces happening at the same time, we use the parallelogram law. That's tail to tail. And finally, for a perfect, precise answer, we use the component method. Just add the i's, j's, and k's separately. So, the main thing to remember is this. You have totally got this. Whether you like to see the answer by drawing it out, or you prefer to get the exact numbers by calculating, you now have all the tools you need to find the resultant vector. So, I'll leave you with a final thought to chew on. Now that you can add two vectors, how do you think a game developer handles a really complex situation? Imagine a rocket is launched in a game. It has its own engine thrust pushing it up, but at the same time there's a strong wind pushing it sideways. How would they combine these two vectors to figure out the rocket's true path? Something to think about.